Hey everyone, welcome back to the channel where we break down cloud architectures and DevOps strategies. Today we are diving into a key concept in high availability load balancing, which is cross zone load balancing. This feature is essential for maintaining resilience and performance, especially when working across multiple availability zones in AWS. By the end of this video, you will understand how cross-zone load balancing works, its benefits, and how it ensures that your workloads are evenly distributed for maximum availability and efficiency. Let's get started. So first, let's talk about high availability in cloud infrastructure. One of the golden rules is to distribute your workloads across multiple availability zones. Why? Because if one AZ goes down due to an outage or maintenance, you want your application to keep running. That's where cross-zone load balancing comes into play. By default, AWS application load balancers have cross-zone load balancing enabled, meaning that the traffic is evenly distributed across all registered instances, across every AZ. Without cross-zone load balancing, traffic is distributed within each availability zone. So if availability zone A has 2 instances and availability zone B has 4 instances, the traffic is split between AZs would be uneven. Let's break this down further. Consider this example. In AZ A, you have 2 servers, and in AZ B, you have 4 servers. If cross-zone load balancing is disabled, the ALB sends 50% of the traffic to AZA and 50% of the traffic to AZB. Sounds fair, right? But wait, each server in AZA will now handle 25% of the traffic, 50% for 2 servers, while each server in AZB only handles 12.5% of the traffic, 50% traffic for 4 servers. This means that servers in AZA are overloaded, while servers in AZB are underutilized. Not the most efficient use of resources, and it can lead to performance issues or even downtime. Now let's flip the switch and enable cross-zone load balancing. With this feature turned on, your application load balancer distributes traffic evenly across all 6 servers, regardless of their AZs. This means each server, whether in AZA or AZB, receives an equal share of the load, which in our case is 16.67% of the traffic. What does this do to your application? First, it optimizes your resources. Every server handles its fair share. Secondly, it improves fault tolerance. If one AZ fails, the traffic will still be balanced across healthy instances in the remaining AZs. Lastly, it enhances high availability. As users continue to experience consistent performance even during failures or maintenance in one AC. Another great benefit of cross-zone load balancing is its resiliency. If an AZ goes offline, traffic is automatically redistributed to healthy instances in other zones without manual intervention. Also, cross-zone load balancing ensures that your resources are used efficiently. Without this, you risk having overworked servers in one AZ and underutilized ones in another, which can lead to higher costs and inefficient resource utilization. Let's take an example of a global e-commerce platform that handles millions of transactions per minute. You can't afford downtime or slow response times. By enabling cross-zone load balancing, you ensure that there is seamless user experience, that the traffic is evenly distributed across servers, ensuring that no instance is overloaded. It also offers continuous availability, that even if an AZ goes down, traffic will flow to healthy servers in other zones. Lastly, it offers cost savings. You're utilizing all your resources evenly, avoiding situations where some servers are overworked while others are sitting idle. To wrap up, cross-zone load balancing is a key tool for ensuring high availability, optimizing resource usage, and improving the performance of your applications. By evenly distributing traffic across all instances in multiple AZs, you safeguard your application against failures and keep your costs in check. If you're working with AWS application load balancers, make sure cross-zone load balancing is enabled by default to get the most of your infrastructure. That's it for today's video. If you found this helpful, don't forget to like and subscribe to this channel for more cloud architecture breakdowns, DevOps tips. Drop any questions or suggestions for future topics in the comments, and I'll see you in the next one. Thank you.